Hey everyone, and welcome. Today, we're going to pull back the curtain on something pretty incredible, the hidden science of building systems that just refuse to break. We're talking about fault tolerance.
I mean, seriously, have you ever stopped to think about it? We rely on these massive, super complex services every single day, and we just kind of expect them to be there, working perfectly. So, how is that even possible? Well, the answer is probably not what you're thinking.
That's right. The shocking truth is that the systems powering our digital lives are in a constant state of falling apart. You've got hard drives dying, servers crashing, network connections dropping all the time. The real secret isn't about preventing failure. It's about getting really, really good at it.
And that brings us right to our first big idea, the art of failing gracefully. This is a total mind shift, you know? It's not about trying to make every little piece perfect. It's about building a perfect system out of parts that you know are going to fail.
This core idea is called fault tolerance. And the best way to think about it is like the spare tire in your car, right? You know you might get a flat tire someday. You don't just cross your fingers and hope it never happens. Nope. You plan for it, you carry a spare, so that one little failure doesn't completely wreck your whole trip. So what do we mean by faults? Well, they usually come in three main flavors. You've got your classic hardware failures, a physical thing, just breaks. Then you've got software failures, the classic bug that makes a program crash. And then there are these weird ghost-in-the-machine ones called transient failures, like a network just hiccups for a second and then it's fine.
So how on earth do you build something that can just shrug off all of that chaos? Well, it all boils down to one surprisingly simple but incredibly powerful principle. Redundancy. That is the secret sauce. That's the whole game. The rule is simple. If a part of your system is important, you never, and I mean never, have just one of them. You have spares, and those spares are always ready to jump in at a moment's notice. And this idea of having spares gets applied in some really clever ways. You can have redundant hardware, right? Extra power supplies, extra hard drives. You can have redundant software. Just run multiple copies of the same program. You can even have redundant information, where your data can literally heal itself if it gets corrupted. And maybe the simplest form is time redundancy. If an operation fails, the system just waits a beat and tries again.
Okay, so that's the theory. But let's check out the undisputed heavyweight champion of fault tolerance in the real world, the massive cloud platforms that basically run the internet. You know, the whole philosophy behind cloud computing is kind of backwards. These companies don't spend billions trying to find perfect, indestructible computers. Just the opposite. They build everything on the core assumption that any single piece of hardware can and absolutely will fail. They literally design for failure. And a huge part of that is geographic redundancy. They use something called availability zones, or AZs. Just think of an AZ as a completely separate, independent data center with its own power, its own cooling, everything. By spreading a service across multiple AZs, you can have a fire, a flood, or a major power outage in one building, and a service just keeps on running like nothing ever happened. So what does this look like in real time? Well, it's like this beautiful automated dance. The system is constantly pinging all its servers. You good? You good? And the second one of them doesn't answer back, bam, it's immediately marked as unhealthy. Traffic gets rerouted to the healthy servers instantly. And here's the magic part. The system automatically starts up a brand new healthy server to replace the one that died. All of this happens in seconds with zero humans involved. All of this automation and redundancy leads to this crazy level of reliability that they call 5 nines. That's 99.999% uptime. So what does that actually feel like? It means you can expect a grand total of about 5 minutes of downtime in an entire year. That's just wild. But hold on, it gets even crazier for data storage. They're aiming for 11 nines of durability. This number is just mind-boggling. It basically means that if you store, say, 10 million photos, you could expect to lose, on average, just one of them every 10,000 years. Your data is safer there than pretty much anywhere else on planet Earth. Now, if you think designing for failure is a radical idea, get ready for this. Netflix took that philosophy and cranked it up to 11. They didn't just plan for things to fail, they decided they would be the ones to break them, on purpose. And this quote from their engineering team just says it all. The best way to be sure you can survive a catastrophe is to live in a state of constant, controlled catastrophe. You have to poke and prod and test your own system's limits all the time. So, to make this philosophy a reality, they built a tool. A piece of software with probably the best name in all of tech, the Chaos Monkey.
The Chaos Monkey's job is as simple as it is terrifying. It is unleashed into Netflix's live production environment, the one you're actually using to stream movies, and its only purpose is to randomly shut down servers. It's the ultimate test of survival. It forces every engineer to build their part of the system with the assumption that it could vanish at any second. Because if your code can survive the Chaos Monkey, it can survive just about any real-world failure that comes its way.
Okay, so after all this talk about chaos and redundancy and monkeys, what's the big picture? What are the key things we should all take away from this?
It really comes down to 3 big rules. Number 1, embrace failure. Stop pretending it won't happen. Expect it and plan for it. Number 2, redundancy is your best friend. Have spares of everything you can't afford to lose. And number 3, automate the whole process. Detection, recovery, the whole shebang. Because when things go wrong, humans are just too slow. So yeah, the next time you fire up a movie or pull a document from the cloud and it just works, you'll know why. It's not luck and it's not magic. It's all because of these invisible, beautifully designed systems that are constantly breaking but are built to never, ever fail. And that kind of leaves us with one last question to chew on. Now that you know about this one, what other invisible, fault-tolerant systems are out there quietly and gracefully failing just to keep your world running smoothly?